Good morning. So I'm Xavier Pereira, the Chief Growth Officer of Quandela. And as quantum computing introduced himself to Vision Golfe, I just wanted to spend a few minutes before the panel to give you a kind of context of what is it quantum computing, So we keep talking effectively about a technology which is really coming to market now and really is going to fundamentally transform a lot of industries. We think about $850 billion of market value which are going to be created within the next 10 years. It's going to impact all technologies and all industries. In a sense, when you think about it, about quantum computing, you need to think about the capacity to solve problems we can't solve with classical computers today. To give you an example, like if you have a problem with more than 100 parameters, you can't solve it with the classical computers, or it would take years to solve it. So you think about logistics, you think about simulation, you think about optimization. There are a lot of areas where we need to apply this. So people like us have built basically roadmaps that start effectively to projects where we think we can have some impact. And I would say in the short term, it's really an acceleration of AI, where we can see that there are some elements of AI processes that can be targeted towards quantum computing. And in the long term, it's really addressing those big challenges we talk about, which are problems, climate change, climate forecasting, simulations, creating of molecules, batteries, that we're going to start to address with this technology. So it's a big challenge. It's going to be bigger than AI. The question is, how do we go there? And what value can you basically get out of it in each of the countries, and I would say particularly in GCC, when you start to put your fingers on top of that technology. It comes with three things. The first thing is you need to have access to a new generation of computers. What's very interesting, for the last 10 years, these computers have started to get shaped. They started with IBM superconducting technologies that really come with the necessity to use very, very low temperatures. So I think there are a lot of players which are moving in this space. At Quandela, we've chosen effectively to express this technology through photons, using light to generate quantum computing processes. Light is very interesting because it has no mass, so it's not impacted by the external environment. It's not sensitive to perturbation. It works at low temperature, so we're not basically requested to have a very high level of energy to make them work, and it integrates very well with the environment. The second element that you need new generation of tools. That's certainly the most important play here, because what we see is with this technology come new capabilities. Like sometimes when we talk about quantum computing, we talked about intrication, entanglements, superpositions. Those are elements that can be integrated within new generation of tools to discover the possibilities of computing, algorithm, primitive, and try to solve differently the challenges we're trying to solve in compute. And so that's a big play, and adopting those new tools, new platforms, helps effectively to move forward with innovation.